Hi, welcome back. So in this part, we will talk about the SQL query language. So first, let's take like these are example tables that we're gonna try to apply SQL to. But the main benefit of having a SQL query language is that SQL is a declarative language, which makes it easy for the user to declare what they want from what kind of data they want to retrieve from the database, as opposed to relational algebra, which was like more of an operational language. And that you have the user or the person who's writing the query in relational algebra has to specify the sequence of operators to retrieve the data. So let's take a look at these examples. So let's assume we have two tables here, S1, S2, and a third table, R1. And S1 and S2 is basically it's two tables that represent sailors. So these are sailors. And the sailor has a sailor ID, name, the rating of the sailor, and the age. S2 also has the same information, but it has different set of sailors. As for R1, these are the reservations that the sailors made for boats. So you have a boat ID, sailor ID, the boat ID, and the day that this sailor with this sailor ID has reserved that boat. So given these instances, we will try to figure out how can we retrieve some information from this very simple schema of the database using SQL. So as I said again, SQL is a declarative language. So you as a user, you only think of one sequence of operations. You don't have to think about how to write things as if in relational algebra, the sequence of operation. So in a SQL, you have three important statements, or in a SQL statement, you have three important keywords. You have select, from, and where. In the from, you have to pass something called the relation lists. Relation lists are the list of tables or relations that you have in the database that you want to apply the query on. In the select, you pass something called the target list. And the target list is, again, a list of attributes, some of the attributes in the relation list that you specified in the from. In the where, you say there are some qualifications. Qualifications are a set of predicates or conditions that are applied on the attributes, some of the attributes in the relation as well. So you can say, for example, attribute, operation, and then you give it a value. And this operation can be larger than, less than, equal, whatever kind of comparative, or a string comparison operator. And all these qualifications are combined using logical operations like and, or, and, not. An extra thing here you can specify is called distinct. And distinct is an optional keyword in the SQL query that you specify when you want to select, to remove all the duplicate rows that are returned from the query. Because by default, SQL does not remove the duplicates. It can return duplicates if there is. So given this the SQL query language, there is only one. As the application developer or the person writing the SQL query or SQL query, you need to think about only one sequence of operation that runs using on the select, from, where. And the sequence of operation is very simple. First, compute the cross product of the relation list. So the relation list, again, you have select, from, and then where. And here you have the relation list. So for all relations in relation list, compute the cross product. And after you compute the cross product, the second step is discard the tuples that do not satisfy the qualifications. Qualifications are in the where clause. So for everything in the cross product that does not satisfy the qualification, you filter them out. And after that, you filter out also attributes in the target that are not in the target list. And if you have the distinct keyword here, you remove the duplicates. So this is the only way the application developer, the only sequence of operation the application developer has to think about. Is this the best way to run the query? Probably not. Maybe, maybe not. So, but the person who writes the query does not have to think about this. This is the job of the database system to figure out the best query execution plan, or the query optimizer in the database system. So if you look at this query, you want to select the sailor's name that's reserved boat 103, the boat ID 103. So the first step would do the cross product on the sailors and the reserves. This is the cross product. As you can see, this whole table is the cross product. And after that, you filter out the tuples that do not satisfy the qualifications here. Qualifications needs to have SID equal SID and boat ID equal 103. As you can see here, is the first tuple, is the SID equal to SID? Yes. Is the boat ID equal 103? No. So this means this will be filtered out. The same you do here, SID equal to SID? No. So this will be filtered out, even though the boat ID is 103. Here, SID equal SID? No. So filter out. SID does not equal SID here, so filter them out. So as you can see, you filter out the result of this cross product based on the qualification that is in the where clause, the qualification list. Third one, you have SID also not equal SID, you filter them out. The last one, you have SID equal SID, which is, it satisfies, so this is great, but we need another condition in the qualifications. Boat ID equal 103, yes. So in that case, the last tuple here in the cross product will be maintained. Everything else will be filtered out. The next step in the query evaluation is filter them out, filter attributes based on that do not appear in the target list, which is in the select clause. The only thing that appears in the target list is sname, so this means we filter everything out, all the other attributes except for sname. And this will leave us, the final result of the query will be sname rusty. So this is the result of the query. The answer that will be returned to the user. So let's look at another example. So we want to find sailors who have reserved at least one boat. What will be the query to do that? So this is easy. One way to do it is to select sailors and reserves, do the join between them, and select SID. What if you want the name? Instead of the SID, you say s.sname. What if we add distinct? If we have two people with the same name in that case, and we have sname, it will return only a distinct name for these. So as you can see, there are several variations. So another example is find SIDs of sailors who have reserved a red or a green boat. So in that case, you have to do a join between sailors, boats, and the reservations. And you want to make sure this is the equi-join conditions. These are the qualification lists. And then you want also to have qualification on the color of the boat, red or green.